Hey guys, so today we're going to do a probability question in regards to probability. It's a pretty big worded one in which you have different probabilities for different events occurring, and we're going to use the tree diagram as well as conditional probability for part B. So here's the information. So there's no actual question. On the next page I'll give the part A and part B. So it should be in the description this. Otherwise just pause the video and write it down. But otherwise I'll just read it out. So a researcher takes a blood sample to determine if somebody has a disease. They found that the probability of a person with the disease returning a positive result, so by positive that means they do actually have the disease, is 0.9, whilst the probability of a person without the disease returning a positive result is 0.03. If you randomly select a person, then they have a 4% chance of having the disease. So looking at this, there are some key features that you should take note. They have the disease returning a positive result whilst the probability of the person without the disease returning a positive result 0.03. If you randomly select a person, then they have a 4% chance of having the disease. So there are two key features. If they have the disease, and two, if it's a positive or if it's a negative result. Another thing to note is that the 4%, so typically that always give all the probabilities as in the same format, but that was just to make sure that you could change the 4% to a usable form, a decimal, which is just 0.04. So make sure you have that down, and then I'll go on to the next slide where the actual question is. So this is part A. What is the probability that a randomly selected person will return a positive result? So hopefully you have a go at this question. So pause it, have a go, see what you can do, and hopefully you can get the answer. So what I start off with is I want to do a tree diagram. So somebody either has a disease or they don't have the disease. So if you remember previously, you could have wrote that as disease with a dash on it, or D dash. And then you can either get the positive result or a negative result. So you don't always have to write all these answers down. You can just do abbreviations such as D dash, PN, or things like that. Now we associate the different probabilities. So if someone has a disease, then they have a 0.9% chance of having a positive result, or a 0.1% chance of having a negative. So where did that 0.1 come from? Well, if you remember, the sum of the probabilities has to equal 1. So if this is 0.9% chance of the positive, then it has a 0.1% chance of the negative. Now if they don't have the disease, the chance of a positive is 0.03. The chance of the negative, using the same principle as above, is 0.97. So we got the second. But what about this? Well, if you look at the last piece of information, the probability that a randomly selected person will have the disease is 4%. 0.04. And using the same principle, we can fill this one in and 0.96. So now we've got a good tree diagram. We can work out the probability that someone has a disease, whether they have a positive or negative result. Someone doesn't have the disease, whether they have a positive or negative result. So now, looking back at the question, what is the probability that a randomly selected person will return a positive result? So what we want, and what we're looking for, is positive results. So it doesn't matter if they have a disease or not? No, it doesn't. All they care about is getting a positive result. So to calculate that, we work out the probability of this one, which is 0.04 times 0.9. Work out the probability of this one, which is 0.96 times 0.03. We get our calculator out. 0.04 times 0.9 gives us 0.036. And this would be a calculator question. I doubt they'll make you do 0.96 by 0.03 on hand and then convert it back to a decimal, and 0.0288. So you add those together, so the probability would equal 0.036 plus 0.0288. So it would equal 6.48%, or 0.0648. So normally I would have done that before and done a bit more working, but I didn't want to go to a new page. So the chance that someone will return a positive result is 6.48%. So now going on to part B. So this is more of a challenging question. What is the probability that somebody has the disease given that they responded positive to the test? So I really want you to have a go, pause the video, have a go at this question, and see what answer you get. So the first thing I pick up on is the given that. So that should be straight away a big pick away that it's conditional probability, as well as the fact that I said that this part B would use conditional probability. So some people might think, I'm not sure what result you got, but they might think the answer is just 90%. That the probability that somebody has the disease, given that they responded positive, is 0.9. But so no, the 0.9 refers to the sort of the other way around. That if somebody has the disease, then they have a 0.9% chance of getting a positive result. So it's sort of the other way around. If they, given that they responded positive, so the person has responded positive, so they have responded positive, do they either have the disease or not? Rather than if you have the disease, what is the chance that if you take a test, it's 0.9? So that is incorrect. So we'll write down the probability, conditional probability formula. So we want the probability of someone having the disease, given that they responded positive. So that's a probability of someone having the disease intersection positive. Remember, intersection is another way of saying both, over the probability of someone being positive. So if you think about intersection as both, that's the disease both positive. Now if you refer back to the tree diagram I did previously, where I had the disease not, positive, negative, positive, negative, then someone having the disease and being positive would be this one up here. So if you remember, positive was 0.9 and the chance of having someone having a disease was 0.04. So the probability of both is 0.04 times 0.9 over the probability of someone being positive. So the probability of someone being positive is 0.04 times 0.9 plus 0.96 times the probability of someone being positive, which is 0.03. So if you calculate that out, you get just put into the calculator 0.04 times 0.9 over 0.04 times 0.9 plus 0.96 times 0.03, and you get a nice number, 5 on 9. So 5 on 9, you just leave the answer as that because it's a nice fraction, but it's approximately 55.6%. But yeah, you just write it as a fraction. So it's interesting how you think, oh, it's probably about 90%, but actually it's 55.6. So if somebody said to you, you responded positive to this test, you only actually have a 55.6% chance of having the disease. So why is that the case? So look back and think, well, the reason for that is even though if you respond positive, that if you have the disease, it's likely that you'll respond positive. The main problem is that you actually have a really high chance of not having the disease. So even though you have a 0.96% chance of not having the disease, you still then have a 0.03 chance, or a 3% chance of responding positive. So that's why he times them together. And even though there's 0.9% chance that if you have a disease, you'll respond positive, so most people that do have a disease will respond positive, we have to keep in mind that only 0.04% of people actually have the disease. So that's a good question, and make sure, especially if you ever see the given that you remember that it is conditional probability. Thanks for watching.